Let's begin lesson 2-13. What are we doing today? We are going to learn how to solve exponential and logarithmic equations and inequalities. To do so, we'll have to utilize our properties, and I'm going to throw in the one-to-one property. You've seen it on a couple lessons, but we're going to deal with that a little bit more today. So today we're exclusively looking at not what's an logarithmic function property, what is a exponential property. What we're going to look at exclusively today is, okay, let's just solve problems. Let's just do straight up math and solve some problems. So that's what we're looking at. As a reminder, there are 3 properties for each logarithms and exponents. That's because they're inverses of one another. I have those written down here in case you forgot them. Plus, there's one more property that I did not include on logarithms that you could write. And that's how you convert. If you want to put the change of base, I did not include that on here. I just realized I did not include the change of base. Change of base property for logarithms is this. If you have the log of base b of c, like that, that is equivalent to log base n of c divided by log base n of b, where a, b, c are real numbers.
Where'd you get the A from?
I don't know. I don't have a, sorry. B, C, and N. B, C, and N. There we go. B, C, and N are real numbers, and your base, your original base should not be negative, nor should it be 1. So I'm going to say it should be, your base should be greater than 0 and not equal to 1. Those are your rules there. So on this slide, you have all your rules. We've taught all of those. That's why I'm not going to spend time with them now. They're there for you to reference and look back at. But there are your properties. And with that, and the conversion between exponential and logarithmic. All right. So with that, I'm going to just start jumping right into solving some problems. I have on this slide some steps that you can follow. If you're looking at solving an equation with only one logarithm or exponential function, you can follow these steps. First off, we're going to isolate the exponential or log expression on one side of the equation. And 2, we're going to apply the blank to convert it to alternate form. What do you think we're going to apply? What converts from exponential to log or log to exponential?
Property. No.
Good thought. It's not a property. It's a word that starts with the I.
Inverse.
Inverse. We're going to apply the inverse. Then we'll solve for the variable and simplify and or round our answer as directed. And my English got bad. I should have said solve for the variable. Solve for the variable. And so that's going to be our steps. This is just for you to look back on. Okay. So there's your steps that we're going to be following all day today. So let's apply some of these. Number 1, part A, we're given this. And so if you remember, the first step on that previous slide said to isolate. Isolate either your log or your exponential. So in this case, what are we working with, a log or an exponential? We're working with the exponential. It's right here. It's the base of 4 raised to the power of x. We want to isolate this. So how do we isolate 4 to the power of x? All right, add 2. So 4 to the power of x equals 9. So now we've isolated the exponential. We've isolated the base and power. So what was step 2?
Converting it into a log.
We apply the inverse. So if I'm going to if I'm going to solve an exponential, I convert it to a log. So you say log, what's the base? 4. And no, not raise the x anymore. Now it becomes raised to the 9, and this would equal x. So that was step 2.
Solve for x.
So x is isolated. We can solve for x right now just by, you can type that in the calculator. So that is your exact answer. This says approximate to the nearest 1,000. Now, question for you. If it's the nearest 1,000, how many zeros are in the number 1,000?
3.
That means we need 3 decimals. So when you type this into the calculator, just type in log base 4 of 9. Which is a reminder, as a reminder, that's the same thing as log 9 divided by log 4. If you type in log base 9, log base 4 of 9, let's see what we get.
Yeah.
This is log base 4 of 9. And in case you are following along, or you're doing your math homework and you only have a cell phone, and for whatever reason you don't have internet, I don't know, I'm making this up as I go, and your cell phone doesn't have the base, you can't change the base. Just as a reminder, what we learned last class, according to change of base, is the same thing as log 9 divided by log 4. As I've typed it in right now, I'm not entering the base. What does that mean the base is if you do not type in a base? 10. But if you type it in like that to your calculator, it would give you the right answer, even if you don't have a phone that has log with a different base. You could do it that way. So what are we going to say our answer is when we round? 1.585 or 584?
585.
585. 1.585 is going to be our first answer. 1.585. Very good. There's our first solution of the day. Okay, let's reload and start with problem B. All right, if I want to isolate either the exponential or the logarithm, what am I trying to isolate in part B?
The exponent.
The x plus 3, is that what I'm trying to isolate?
Well, not that you're trying to isolate 2 raised to
That whole term, 2 to the power of x plus 3. So how would I solve that?
subtract 5 on both sides.
Subtract 5. And so 2 to the power of x plus 3 equals 21. Okay, now this is exponential. We've isolated the exponential expression. So how do I solve from here?
Convert it to a log.
Please apply the inverse. So it's log. What's our base?
2.
And are we still raising it to the x plus 3?
2.
Now we're raising it to the 21 equals x plus 3. Very good.
Now we'll just solve it and then add 3.
So we could type it in the calculator now, but I'm going to do one thing beforehand. How would I isolate this x? This time we will have 4 steps. Unlike this one, we only have 3.
Divided by.
We'll subtract 3. Now, when I subtract 3, will I subtract inside this logarithm? Well, to answer that, come over here. When I subtracted this 3, am I subtracting inside of a logarithm?
No.
No. So neither will this 3 subtract inside a logarithm. This will stay on this minus 3 will be on the outside like a vertical translation. It'll be somewhat equivalent to that. So it'll be log base 21 minus 3 on the outside like that. That would equal x. Now there's our exact answer. Let's type in the calculator and approximate this answer to the nearest 1,000. So let's go type that in and see what we get to the nearest 1,000. Log base 2 of 21 minus 3. That's what we're looking for here. Log base 2 21 with the minus 3 on the outside. What are we going to say? 1.392 or 393? 1.392. Very good. All right, let me go ahead and insert my calculations in for later. In case you want to look back at the notes. Okay, what about part C here? What are we isolating this time?
Four and
The -4e to the power of x. Now, and I'll actually isolate even further than that, but let's just begin with, if we're trying to isolate the e to the power of x, the base raised to the power, what should we do first?
subtract 3 on both sides.
We want to subtract 3 on both sides. So we have a -7 minus 3 more. Does that turn to a positive? Do two negatives make a positive when you're adding and subtracting? No. So what's a -7 minus 3 more? -10 equals -4e to the power of x. Well, we're still not isolated. We're going to try to isolate this base in the power. So what's what's that -4 doing to the e to the power of x? Multiplying. What's the opposite of multiplication? Division. So we're going to divide both sides by -4. Now, do two negatives make a positive when you multiply or divide?
Yes.
Yes. So these two negatives will become a positive. 10 over 4 can reduce. What number goes into both 10 and 4? 2. I'm going to say that is the same thing as 5 halves, or you'd say 2.5 e to the power of x. Is it isolated now?
Yes.
So to solve an exponential, what do we do? Convert it to a log. I have log of, what's my base? E. What log of e is the same thing as natural log. So we're gonna have natural log. Is it still gonna be raised to the x? Now what's it raised to? 5 halves will equal the x. There's your exact answer. I'll let you go to the calculator and let's find out what an approximate answer is. We'll round that to the, again, the nearest 1,000. And so I'm going to prove to you here log base e of 5 halves is going to be the same thing as natural log. I'll prove it to you here. Natural log of 5 halves. And what will we say our answer is this time? 0.9. 0.916. All right, 0.916. All right, you have your first DOL up. I'll give you a moment to work on this one. All right, now what we're going to do is look at some log. Let's solve some logarithmic expressions, or equations, I should say. For each of the following, write an equivalent equation by condensing each equation to a single logarithm and then solving for x by approximating the nearest thousandth again. All right, so same steps here. This time I want to isolate this logarithm right here. I hear subtract.
Subtract 4.
I agree. Can I subtract 2?
No.
Why not?
2 is multiplying a lot.
2 is multiplying, so that would not be the opposite. Operation is the word I was looking for. Opposite operation. It would not be the opposite operation. Whoops. So we have 2 log base 3 of x plus 3 equals 6. Okay, now what?
Divide by 2.
Divide by 2, because once, like we said, that 2 is multiplying, so we divide by 2. And so I'm left with log base 3 of x plus 3 equals 3. Question, is this isolated?
No.
The log is not isolated? Actually, I would say it is isolated. So how can I solve an isolated log?
We're getting to the next page.
Convert to exponential. So what's my base?
3.
3. What's my power? 3 equals x plus 3. You don't need the parentheses anymore. So I'm one step away from solving this. Now what do?
Subtract it.
We subtract 3. Now, can I take that away from either of those 3's? No, because they have a power. You might know what 3 cubed is. I'm going to write it as if I don't know. So I have 3 cubed minus 3, which will equal x. You could type that in the calculator, but you will find out that 3 cubed is how much? 27. When you subtract 3, we get 24. And that's our solution to part A. It's 24. Okay, let's reload and try that again. All right, the second logarithm. How do you think we could solve this? Subtract 2. Why subtract 2? Because it's currently adding, and the opposite operation would be subtraction. So I have log base 5 of 2x minus 1 equals 4 minus 2 is 2. Now, am I isolated?
Yeah.
Yes. So I'm moving to my next step. Once I've isolated, I need to do the inverse application to convert operation, excuse me, to convert to an exponential. So what's my base? 5. What's my power? Equals 2x minus 1. Now, as we go to solve this, I'm assuming you probably know what 5 squared is. 25. So how would I get x isolated from here?
Divide 5, subtract 1, add 1.
We're going to add 1. So this is 25 plus 1, not 6 squared. It doesn't become 6 squared. It doesn't become 5 cubed. It's 5 squared. That doesn't change. I cannot combine that 1 with it. But I can say, what is 5 squared? 25. I can say this is 25 plus 1, which is 26. 26 equals 2x, which brings us to our last step. How do I isolate this x? 2 is multiplying, so the inverse application with operation, I should say, is to divide. 26 divided by 2 is 13. Very good. Alexis. Great. Let's reload. See it again. How about part C? What type of function is this? It looks like IN. It's a natural log. It's not an IN, is it? It's an LN, like Ellen DeGeneres. It's an LN, natural log. So how do I isolate this natural log? I multiply by 5. Right now it's being divided by 5. So if I multiply by 5, the inverse operation. So I have natural log of 2 minus x equals 5. What now? The logarithm is isolated, so we convert it to exponential. What's the base if it says natural log? So it's a base of e to the 5th power equals 2 minus x. Now this I'm going to hold off on typing the calculator till the very end. How do I get rid of this 2 here?
Subtract 2.
I subtract 2. Very good. I'm not adding 2 because this 2 is positive. I'm subtracting 2. Now, question about the math work here. Do I change this to e cubed?
No.
No, that's not a power. So I just need to write it as
E to the power of 5 minus
e to the power 5 minus 2 like that.
then divide by a negative.
Equals negative x. And so you can divide by negative 1. This is like being multiplied by negative 1. So we can divide by negative 1. That's essentially what's happening right there, is it's being multiplied by negative 1. Okay, so if I write that out, I can now go to the calculator and get my solution. Hang on 1 second. My solution will be, well, I'll rewrite it one time. Here it is in exact form. The negative 2 becomes a positive 2. The e to the 5th becomes a negative e to the 5th. So there it is in exact form. But I want you to type that in the calculator and round that. So let's go to the calculator and get an approximate answer here. So it'll be 2 minus e to the power of 5. That's going to be our solution. So to the nearest thousandth, we need 3 decimals. So what are y'all thinking? 0.413 or 0.414? Okay, so X is approximately negative 146.413. And now I'll let you work on your DOL. See what you come up with. So now let's move on to example 3. So what we're going to do now is what happens when there's more than one exponential or more than one logarithm. That's what we're going to go through to now. From this rest of this point on is what happens if there's more than that. Now there's two different methods. And so one is if you can apply properties and to get it to become one log or one exponential, then do so and solve just like we've been doing. Or step 2, or the method 2, I should say, is to use the one-to-one property. Okay. So when we do this, it's going to be imperative that we look for extraneous solutions. You know what an extraneous solution is? It's when you come up with an algebra answer, but it's not actually a good answer. And I'm going to show you some pretty quickly that are not good answers, but that we can, through using properties, obtain. So we'll call those extraneous. So let's begin here. What do you notice is different on part A here?
That they have the equal sign.
I would say what's different is I have multiple logs. We had equal sign on every problem so far today. What's different here is I have multiple logs. So what I'm going to do is to help myself solve this, I'm going to use log properties. What have we learned we can do when we have two logs with the same base? By the way, what is the base if you don't see it? And it says the word log. It's a base of 10 all the way across. What can I do with these two common logs here that are adding?
Just multiply. So
Multiply them. This becomes log of 12. Now, how do we get that? That was called the what property?
Product property.
Product property. Now, again, if you forgot your properties, if you go back to the front of your packet, on the second slide, I gave you all those properties. So log 12 is going to equal log 5x minus 2. So what we did here is the product property. Two logs adding is the same thing as one logarithm with the values multiplying. Okay, so now what I can do is apply what's called the one-to-one property. If you have an equation and you have two logarithms, and each side of the equation is isolated for one of those two logarithms. So over here, is there anything besides the log 12?
No.
Is there anything over here besides this log as well? No. You can do what's called the one-to-one property, which means this. If I have log of 12 equaling log of 5x minus 2, that means 12 must equal 5x minus 2. This must equal 12 so that these would be equal. So what I'm going to do is called the one-to-one property. It's where you drop those logarithms. So 1 to 1 property. That's what I'm doing now. The one-to-one property. And it's going to state that 12 will equal 5x minus 2. And so now I'm just going to apply some algebra 1 here. How would I isolate this x? Add 2. So 14 is going to equal 5x. And so the last step here, what's that 5 doing to the x? Right now, what's it doing? Multiplying. So the inverse operation would be to divide. The opposite would be to divide. And so x is 14 over 5. You could write the answer as 14 over 5, or it's almost 3, not quite 3. Does anybody know exactly what it is? Is it decimal? It is 2.8. Think about it this way. 5 goes into 14 how many times? 2 with the remainder of 4. Put the point there. You would add a 0. 5 would go into 48 times. It is 2.8. That's your answer right there. Now, let's check to see if this is extraneous. What does it mean? It means when you plug it in that the math would not work out right. So usually with the logarithm, what that means is when you plug it in, you get a negative log. Let's check it. If I plugged it in right here, well, I have 5 times 2.8. We know what that should be from right there. What is 5 times 2.8? 14. So what's 14 minus 2? 12. Now, would that equal log 3 plus log 4? Yeah, so this is a good answer. That's a great answer. It's not extraneous. It's a good answer. Just leave it as it is. Now let's come over here and check out this problem. This looks like IN. Is that what that is? No, it's natural log minus another natural log equals a natural log. How can I solve this with three natural logs?
So you do the quotient property.
Quotient property. So the quotient property states that two logs subtracting is the same thing as one log, in this case natural log, with division. The positive natural log becomes the numerator. The negative natural log becomes the denominator. Now that's the quotient property right there. Okay, so now I have a natural log isolated on the left side of the equation. I have a natural log isolated on the right side of the equation. How can I solve once I have them isolated on both sides of the equation?
Cancel out the terms that are in the other side of the division. So like you'll cancel out the x and then the bottom part will come to it.
No, can't do that. But I can do something else that I did over here.
Cancel the natural.
We can simplify out the natural logs, because if natural log of all this is equal to the natural log of 7, then all this on the inside has to equal 7. This is called what property? The one-to-one property, meaning one log equals to one other log. And that's it. It's not a 1-to-2 property. It's not a 2-to-3 property. It's a 1-to-1 property, meaning one log equals one log. So dropping that, I have that x plus 1 over 3x minus 5 equals 7. How could we solve from there?
Combine like.
So I don't have any terms that I can combine right now. I can't cancel out this x. These would be canceling terms. You can cancel factors. You cannot cancel terms. I heard multiply. Multiply what?
3x minus 5.
That's right. Let's get rid of this denominator. 3x minus 5 is in the denominator. Let's multiply both sides by 3x minus 5. Now that will simplify out the denominator. So I'm left with x plus 1 equals, what's 7 times 3x? 21x. And 7 times negative 5? Negative 35. Now I want to go back to what I heard a student say a moment ago. It was 3 words, started with the C. First word.
Combine.
Combine
That's it.
like terms. What terms do we have that we can combine? How about the x's? How can I combine this x and this 21x? How about let's subtract the 1x. I like doing it this way. Subtract 1x. Okay, what about the 1 and the negative 35?
Add 35.
Let's add 35. I agree with that. So we're combining our like terms now. So I'll combine like terms. And so what do we end up with? Well, let me simplify that out of there. What's 1 plus 35? 36. And then 21 minus 21x minus 1x is, okay, almost done. Last step. We divide by 20. Now, 4 can go into this. So I could say 4 goes into 36 how many times? 4 goes into 25 times. And that's the same thing as 1.8. So we can say this is our answer. But we might have a problem here. When I go to plug this in, if I go up here and plug in 1.8 over here, this is just fine for the logarithm. Remember the domain of a logarithm. The domain is the values have to be greater than 0. They cannot have a 0 logarithm or a negative logarithm in here. So I plug in 1.8 here, I'm fine. What's 1.8 plus 1? 2.8. I'm fine. Over here, though, I might run into issues. What is 3 times 1.8? 5.4. Very good math there. 5.4 minus 5 is 0.4. Oh, I'm good. Never mind. I thought it was going to be a bad answer. This is a good answer. I thought it was going to be. I thought I was going to get a negative logarithm there. I was doing bad mental math. That should work. If you solve that equation to check in your calculator, it should work. All right, well, let's see if I have an extraneous solution on this side then. Okay, let's look at part C. And see if we can go a little bit quicker through these properties. What can I do when I have two logarithms adding? Multiply. So we're going to say this is the same thing as log base 3 of x plus 2. I'm going to rewrite this a little different. X plus 2 times x minus 3. Right, like that. So you can see what I'm doing. I'm making it one logarithm. And I am doing, what property is that? The product property there. That is the product property. So let's simplify. We've got a trinomial. Chris. Come on now. And your hoodie. I got a trinomial. Let's multiply here. I have log base 3. By the way, actually, we could do one-to-one property just so it's easier. Let's not write as much. If I simplify that out of there, because I do have them isolated, that's the one-to-one property. I'm left with x plus 2 times x minus 3 equals 14. Moreno. Me. Okay. What is x times x? I'm going to FOIL this here. I'm distribute. X times x is x squared. What's x times 3? Negative 3, I'm sorry. X times negative 3. Negative 3x. I need to have 2 times x. And 2 times negative 3. Equals 14. That was this distribution. That's all I did there. I distributed. Which some people call FOIL. Okay, so how can I solve from here?
Add 6. I mean, combine like.
Let's combine our like terms. What like terms do we have? Yeah, and I'm also going to, because it's a trinomial, well, it'll become a trinomial, I'm going to subtract my 14 across. So I now will have x squared minus 3x plus 2x is negative x, and minus 6 minus 14 more. Negative 20 equals 0. That was combining our like terms. Whoops. Now, what do we do from here? Well, let's think about this. You have a polynomial, a trinomial expression here equal to 0. We learned in algebra 2, the zero product property states that if you can turn this into factors, the only way to multiply and get 0 is to multiply by 0. So the way to solve this is to change this into factors. So the way to factor is to use X method. It's the best way I know of. Remember A, B, and C. You put the factors of A times C in the top. What is 1 times negative 20? And you look for factors of negative 20 that add up to negative 1, which would be the B. What are your factors? Negative 5 and 4. Do you agree with that? Our factors of 20, just doing the positive numbers, would be 5 and 4, 2 and 10, 1 and 20 would be the 3 options. But to combine to be a negative 1, that would have to be a negative 5 and 4. So that works. And so if I'm going to factor here, that's what I'm doing. I'm factoring by X method. What I do now is I split this power. And so it becomes, instead of x squared, it's going to be x times x like this. That's my x squared. To make up these terms, we're going to have it as a minus 5 and a plus 4.
And is that it?
You would think that's it. But now I have to solve, what is x actually equal? According to the zero product property, what's the only way to multiply and get 0?
0 by 0.
Multiply by 0. So either here, x equals what number? 5 or negative 4. Now that's according to the zero product property. Let me write that here. Zero product property. But now we have an extraneous solution. I know we do this time. How do I know? Because when you plug this in, if I plug in a 5, I'm fine. What's 5 plus 2? 7. What's 5 minus 3? 2. Log 7 times plus log 2 is the same thing as log 14. Even with base 3s, it's still the truth. 7, a logarithm with a 7 plus a logarithm with a 2 becomes log 14. So that would work. However, when you plug in a -4, we have a problem. What's -4 plus 2? Can you have a negative log? No. So what I'm going to do here is my actual answer, that the -4 is not going to be, that's extraneous. So what I'm going to do is I'm going to mark that this is an extraneous answer, that is extraneous. So my only answer is x equals 5. Extraneous answers are not true solutions. Once again, are extraneous solutions true solutions? No. So you don't include it. That's extraneous. It's outside the domain of possibilities. So that's why it doesn't work. If logarithms had a negative domain, then it could work, but it doesn't. So that's why it does not work. Go ahead. That'll be an easy one on the test. All right, let's do it one more time. Here we go. This time, can I just combine these two logs right away together? No, why not? That 3, what can I do with the coefficient of 3? I can make it a power according to which property?
Power property.
Power property. According to the power property, I can say that this is log base 4 of x minus log base 4 of 2 cubed, which equals log base 4 of x plus 7. Okay, now that I have these two logarithms with a coefficient of 1 or -1 in this case, what property could I now use? The quotient property. We could say that this becomes 1 log base 4 of what goes to the numerator? X. Anything originating from a positive log goes to the numerator. Anything originating from a negative log goes to the denominator. I'm going to make a substitution. What's 2 cubed equivalent to? 8. That is equal to log base 4 of x plus 7. Now that was the quotient property. What can we now do? What do you think, Jonathan? What do you think we can now do?
You could take up the logs.
Okay, what property is that? 1-to-1 property. So we'll say x over 8 equals x plus 7. Okay. Now what? Abdiel, what would you do from here? Multiply by what? Good job. We're going to multiply by 8. 8 needs, and multiplication distributes. So that will cancel there. And so I now have x equals, what's 8 times x? And 8 times 7? Okay, to solve this, all we need to do is
Subtract the x.
we can combine our like terms. So just to cut down a step, I'm going to subtract 8x. So what's x minus 8x? Negative second x, that equals 56. And last step, divide by -7. All right, and so what are we getting that x equals? -8. Okay, let's check that. Now with logarithmics, a lot of times your answer is going to be x is either, it's usually a positive number. So let's check. -8 should alert us. When you plug in a -8, would this logarithm still be positive?
No.
No, this is an extraneous answer. So if that is an extraneous answer here, let me go ahead and mark that, if that's extraneous. How many good solutions do we have?
Zero.
None. This is no real solution. No real solution. All we had was an extraneous value. That's not a true solution. That would be outside the domain. You graphed it, the graph would not extend to the -8. It actually would not even go to the left of the y-axis. All right. I have 2 DOLs for you here. You can work on now. Let's take a look now at example 4. It says let f of x equals the natural log of x plus 10 minus natural log x, and g of x equal natural log of x plus 3. Find all values of x where the graphs of f and g intersect, which means we want to know where are these two equal to one another. If they intersect, what that means mathematically is that f and g have to equal each other. That's where they would intersect. Now, we'll graph this in a moment, but before we do, I'm just going to work you through the algebra. If I were going to say these were equaling to one another, you would substitute. Well, what is f of x the same thing as? The natural log of x plus 10 minus the natural log of x. Now, what's g of x the same thing as? Natural log of x plus 3. All I did there was substitute in. Now, what property could we use if we have the natural log of x plus 10 minus the natural log of x? Quotient. So this becomes the natural log. I'm going to use a square bracket to make it easier. X plus 10 times x. I'm doing the quotient. No, I did that wrong. Correct me. What did I do wrong? I did the product property, but that's not accurate. I need to do division. Because of that, I don't need the square bracket. I can go parentheses. I'm sorry. So I'll do x plus 10 in the numerator over x in the denominator. And I can just do a parenthesis like that equals the natural log of x plus 3. Now, how do we solve that?
Multiply by x.
Multiply. Nope, not
One property, but then you
multiply 1-to-1 property. So each logarithm, each natural log is isolated. So I'm going to do 1-to-1 property. So x plus 10 over x equals x plus 3. How did you say we'll solve that?
multiply by x.
We're going to multiply by x on both sides. To clear myself some space, I'm just going to slide these over now. Okay, so I'm multiplying by x on both sides. I'm multiplying by x on both sides. So over here, this simplifies. And so I have x plus 10 equals, let's distribute that. What? X squared plus 3x. This looks like we're going to have to use zero product property again. So I'm going to combine my like terms by, I'm going to subtract x and subtract 10. Subtract x and subtract 10. I'm going to do this because I see I have a polynomial function with power greater than 1. Because of that, what I want to do is set it equal to 0 and factor to get my solution. So I now will have 0 equals x squared. What's 3x minus 1x? Plus 2x minus 10. We're not going to have very good answers here. If you try to X method, you're going to run into problems. Factors of -10 that add up to 2.
They don't exist.
Not as integers. Y'all want to know this? The shortcut?
No.
Shortcut's this, without doing the quadratic formula. You take your b and you always divide it by 2. What's half of? Sorry, you take your b and divide it by 2. Yeah, I said that right. So what's 2 divided by 2?
1.
Put 1 on both sides. and then do a plus or minus with the square root. So the two values are going to be 1 plus a square root and 1 minus a square root. So what happens when you multiply, these are conjugates. You'll have 1 squared, which is 1, and then you'll have plus and negative. What happens when you have multiply a positive times a negative? It'll be the negative and the square root squared, so that it'll cancel out. So here's my question. If that's 1, 1 minus what number gives me negative 10? 1 minus what gives me negative 10? And you can do your math here real quick. It's 11. I'm off on the time, huh? Those are our values. Only one of them would be good. X plus the square root of 11 times x minus the square root of 11. One of those will be extraneous. That one's extraneous. This one is good.